I think we'll get started now. This is the second part of the first chapter on Introduction to Chemistry, Ahana. So let us continue and really make this inspiring, right? So when we talk about the part where proper scientific methods began to be developed in the early 17th century, early ideas that later became incorporated into modern science of chemistry came come from two main sources. Natural philosophers such as Aristotle and Democritus used deductive reasoning in an attempt to explain the behavior of the world around them. Alchemists were people who used to experiment techniques. In the 17th century, a synthesis of the ideas of two disciplines, that is the deductive and experimental. There are two different ways, deductive and experimental, lead to the development of the progress of thinking known as the scientific method. In the 17th century, there were two kinds of methods, deductive and experimental. Now, what is deductive and what is experimental? So, by experimental, we mean that you experiment certain things to get certain conclusions. When you do deductive means when you have when you kind of say that the earth is round, you look at the stars and you say, okay, they are moving on the left, and through certain calculations, and you say this is not possible, that is not possible, okay, we go and meet in the same place when you go around the earth. So you kind of deduce certain things and come to a conclusion. You necessarily don't have to experiment every time. Robert Boyle gave chemistry the status of a science itself by encouraging scientists to prove their theories with proper experiments. He started the every phenomenon was due to the collision of particles in motion. Collisions of particles in motion. Now, this is a very important part. If you say collisions of particles, this is a solid material, but there are small atoms that are basically moving very fast, and it's a collision of atoms that make an, a shape like this. So he was the first to use in indicators which change the color. He formulated the Boyle's law of gases. For all his contributions, Boyle is considered to be one of the founders of modern chemistry. Throughout the 18th century, the study of chemistry threw up new discoveries. The gases, carbon dioxide, hydrogen, oxygens were isolated separately. New metals such as cobalt, nickel, tungsten were found, and new concepts were put forward. In the early 19th century, John Dalton put forward his atomic theory. John Dalton, what did he do? He put forward his atomic theory. The Russian chemist Dmitry Mendeleev arranged all the known elements in increasing order of the atomic masses in the periodic table of elements. He was able to predict the properties of elements still undiscovered. Predict the properties of elements still undiscovered. Imagine, Russian chemist Dmitry Mendeleev. Now I'll teach you a lot about periodic table. I know it by heart. Okay, the husband-wife duo Pierre and Maria Curie, along with Henry Becquerel, discovered radioactivity. The husband-wife duo Pierre and Maria Curie, along with Henry Becquerel, discovered radioactivity. Again, husband-wife duo Pierre and Maria Curie. Maria Curie is very famous, and she discovered radioactivity. By radioactivity, what comes to my mind is, if you know the atom bombs or the nuclear fission and fusion reactions, they basically cause from radioactive materials, right? And Madame Curie, Maria Curie, was the first, or we also call her Madame Curie, is the first person who discovered radioactivity, through which these days the Japanese Hiroshima Nagasaki incident happened due to the atom bombs. The husband wife duo Para and Marie Curie, okay, in the first half of the 20th century, rapid strides were made in understanding the structure of atoms by Ernest Rutherford, Max Planck, Niels Bohr, and James Chadwick. In the first part of the 20th century, rapid strides were made in understanding the structure of atoms by Ernest Rutherford, Max Planck, and Niels Bohr, and James Chadwick. In today's space age, more exciting. So, what did they do? In the first half, understanding the structure of atoms. Okay, Ernest Rutherford. In today's space age, more exciting and complex discoveries were waiting to be made. So, let us see overall chronological timeline of the advancement of chemistry. So 2 million years ago, first was discovery of fire. About 60,000 BC, naturally found materials were used to make tools and weapons. Naturally found materials like rocks and stone and all those things, bone, right? 3500 BC, bronze, an alloy of copper and tin. Bronze, an alloy of what two metals? Copper and tin. Okay, then 1200 BC, the Iron Age happened. Iron Age. Then 350 BC, Canada and Democritus declared matter is made up of small invisible particles in motion. Between 5th and 15th century, alchemy during the medieval ages. In early 17th century, the scientific method developed by Boyle's law based on theories with proper experiments. 18th century, discovery of carbon dioxide, hydrogen oxide, cobalt, tungsten. In the 19th century, Dalton's atomic theory, periodic table discovered of radioactivity. So 19th century, Dalton's atomic theory, periodic table discovery of radioactivity, right? That's what happened. In 20th century, discovery of electrons, protons, neutron, and atomic structure. I will explain in physics class how this proton, neutron, and electrons work. So basically, neutron is like a ball, right? And there are protons and electrons oscillating around it, right? And we will learn more in the physics chapter about them. Then the first chemical reaction used by man, what? Fire. Alloy made of tin and copper was b- bronze. John Dalton, right? John Dalton discovered what? We just read here. John Dalton. Do you see? Dalton's atomic theory. So, John Dalton discovered atomic theory. Arrange elements in the order of atomic mass. Dmitry Mendeleev. Pierre and Maria Curie discovered radioactivity. Okay, so that's what we finished that. Then make a linear flow chart. Okay, the magic of chemistry. Then after that, we have got, I think, cellular respiration and all those things will happen. Definition of chemistry. So let's see how much we have achieved so far before going into the next chapter.